Python machine learning. So for this video, we'll be discussing about linear regression and how to use this one to predict values. So regression. The term regression is used when you try to find the relationship between variables. So in machine learning and in statistical modeling, the relationship is used to predict the outcome of future values. So we'll be trying to determine the relationship of variables. Let's say, for example, the speed of a car and the age of a car and other variables. So linear regression. Linear regression uses the relationship between the data points to draw a straight line through all of them. This line can be used to predict values. So here, for example, these are the values, and maybe we can produce a linear regression basing from these values. So in machine learning, predicting the future is very important. So we can predict the values. So let's say, for example, if these are the age of the car and the speed of the car, so what will be the speed of a car if it is around 10 years old? So we can get the value. What if it is around 14 years old? So we can get the value. Now, how does this work? Python has methods for finding a relationship between data points and to draw a line of linear regression. We will show you how to use these methods instead of going through the mathematical formula. In the example below, the x-axis represents age. So this is the x-axis. This is the age of the car. And the y-axis represents the speed of the car. We have registered the age and speed of 13 cars as they were passing a tool booth. So let us see if the data we collected could be used in linear regression. So this is an example. So we import matplotlib because we're going to plot the data. And then we have here x. These are the age of the cars. And y are the corresponding speed of the cars. And then using scatter diagram, so this one, we plot x and y and then show this will be the output. So these are the data that we have plotted here. Okay, so let's say, for example, 2, the speed of 2 is 111. So 2, 111. Okay, so we also have 2 and 103. So 2 and 103. So this is the scatter diagram, scatter plot, etc. Now, here we import the scipy and draw the line of linear regression. So this is the line for linear regression. So basing from this, we try to detect or draw a line for linear regression. So here we import matplotlib pyplot as plt. So we're going to plot the diagram. And then from scipy import stats. And then we have here, so x, these are the values of this age, and y are the speed. So now we use this function from this module for linear regression. So this will, by plotting x and y, or by using x and y values, this will produce the following values. We have slope, intercept, r, p, standard error. Okay. Now, to plot this one, we need this the value of slope. So to plot this, we use the value of x here, but we have to determine the y values. Okay, so but we were able to get the slope using this function. And in mathematics, I'll be showing you a formula. So where is it? No, nawala. Wait, I think it's here in my Google. So here's the formula to get the y value. So m here is the slope, x is the value of x plus the intercept. Okay, this is the intercept. And we can get the value of y. This is the formula to get the value of y. And that is what we have placed in this. So if you're going to look at our PowerPoint presentation, so slope times x plus intercept. And notice here we have the value for the intercept. So that is to get the value of y. And then here, we now get the value of y and place it in a list using this function. So map and then my this is the function here, and using the value of x. So this will create a list of the new value of y for the linear regression. And then this one will of course show the scatter plot. This one will now plot the linear line here, our chart for our linear regression, and then show. So it will now show both diagrams, the scatter plot and our linear regression diagram. So x and my model was based from this, basing from the formula that I have shown you a while ago. Y is equal to mx plus b. So m is the slope, x, and then the intercept is b. That's the intercept. The value that we have derived using this function, the lin regress function. Now, so how do we do this? So import the modules you need. So we have done that one. We have matplotlib and plt. So this one is used to plot the diagram, and this one is for the statistics. Then create the arrays that represent the values of the x and y. So x and y. If let's say for example, you're using actual data, then this data can be derived maybe from a CSV file. So you have learned previously how to read CSV file, so you can get the value of x and y, for example. Then execute a method that returns some important key values of linear regression. So it starts that lingress. So we have the values of x and y, and we can have these values. So these are the important values for linear regression, of linear regression. Okay, and then so here we will be able to get a slope, intercept, r, p, standard error. So r will be explained later. Create a function that uses slope and intercept value to return a new value. This new value represents where on the x or where on the y-axis the corresponding x value will be placed. So we're trying to get where the y-axis, the value of y. So this is the function slope times x plus intercept. As I've said, this was based on this function. Y is equal to slope x plus b, the intercept. So yeah, b is the intercept. And then run its value of the x array through the function. This will result in a new array with new values for the y-axis. So we run this function using the values of x, and this will create a new list which will create the new values of y and place it in my model. Then we draw the original scatter plot. This is the original scatter plot. And here we draw the linear regression. This is the value of y we have created from this, and then show. So this will show both of the diagram. So in other words, we have seen here that this data can be represented by this line in linear regression. Okay, so we can more or less, based from this, is that the speed lowers as the age of the car increases. So that's more or less the relationship that we have seen from this diagram. Now, one important thing is the R value. So it is important to know the relationship between the value of the x-axis and the values of the y-axis. So that's the relationship. If there are no relationship, the linear regression cannot be used to predict anything. So we have to determine this. That's why this is also known as the supervised machine learning. So because we have to first determine if the relationship is a good fit. So this relationship is called the coefficient of correlation, or it's called R. The R value ranges from -1 to 1, where 0 means no relationship and 1 and -1 means 100% related. So Python and scipy module will compute this value for you. So we don't need to do statistics because it will already be computed for us by Python and scipy. All we need to know are the X and Y values. So that's what we have done here. So how well does my data fit in linear regression? So these are the values. We use slope, intercept, so the same function, but here we just print the value of R to determine the relationship. As we have said here, 0 means no relationship and 1 means 100% related. So if we get a value that is almost equal to 1, or equal to 1, or maybe a lesser equal to 1, then that means we have a good relationship of the two variables. So there's a relationship between, or there's a correlation between the two variables. So in this example here, we got a value of 0.76. So the 0.76 is not a perfect relationship, but it's already a good value to indicate, to predict using linear regression. So yeah, the result 7.6 shows that there is a relationship. And again, it's not perfect because it is not equal to 1, but indicates that we could use linear regression in future prediction. So that's a good value, good enough to use linear regressions in future predictions if the data will be based from this. So here's an example of predicting the value. So since we already know that there is a relationship, okay, so since we know that there is a relationship, we can now use this data here to predict values. That's why we call it machine learning. So the computer will learn from this, and we can now predict values. So we can use the information we have gathered to predict future values. So let's try to predict the speed of a 10-year-old car. To do this, we need the same function, the myfunc function from the example above. So again, the my function, that's the slope times x plus the intercept. So how do we predict now the speed of a 10-year-old car? So based from this data, we compute for the slope and intercept using this function. So speed now is equal to myfunc 10, and the speed is around 85.59. So we have now predicted the speed. So if it is 10-year-old car, then most probably the speed will be around 85 or 86. So if you're going to take a look at the diagram here, so the example predicted a speed of 85.6, which we also could read from the diagram. So here is the age, and that's the y value, or 85 point something. So that's 85.6. So here we were able to predict the value using linear regression. So here in actual, we can have data. Then first we have to know if the model is fit for linear regression. So that means we have to get the relationship, or the coefficient of correlation. If there's a good correlation between the two variables, then we can now use linear regression, as in this case, of course using the function lingress to determine the correlation. So if the value is high for R, then we can use the linear regression to predict values. However, there can also be an example of bad fit. So let's say, for example, we have these two values. Okay, then we computed for the slope. You notice here, so we have this one, and then we plotted the two values the same, And we have this one. Although basing from this, we cannot find actually a relationship even just looking at the diagram. Okay, that's why if we compute for R is 0.01. It's a very low correlation. It's very far from 1, the perfect correlation. So that means that we cannot use linear regression here. That means that there are no linear relationship of the two when it comes to linear regression. So maybe we can use other method, not linear regression. And those method or the other methods will be discussed in the next videos. So that's all for this video, and thank you very much for viewing this video. Thank you.